1700 to the tire. Like I said, stuff is gonna move around, things are gonna wear.
Is there anything scary in there?
That's what we're about to find out, so.
Put the money in the right spots first.
Are we still not allowed to look at the cam bearings?
Decided to quit school, quit college, and go to the trade school to learn how to build race engines.
How did your parents feel about just quitting everything? Like, I'm gonna quit everything, go to Texas for race cars.
They were
It is 6:30 in the morning. Back of Elvis is the Escalade's 427, at least the short block of it. Today, we're going to Late Model Engines in Houston. We're gonna tear it apart, check it out, go through it with those guys, do a bit of a facility tour. It's gonna be freaking sweet. Well, I am almost there, and we got a problem. My dang wiper just flew off. It's gone. No reason, just decided to. But good news is I'm about 10 minutes from LME, so we'll just not use the wipers until then, because I don't want to scratch the crap out of my window. We made it. Pretty neat place. I haven't seen anybody yet, but I see a bunch of oil on my bumper, so kind of thinking the motor might have tipped over. I really didn't drain it. Just sort of pulled it out and stuck it in there. That's what she said. Or maybe that's what he said to her. I don't know. There might be a mess, but that's okay. Elvis is tough, he can take it. I'm gonna go in there and find somebody to see what we're supposed to do with this thing. Well, you know what I forgot to do when I strapped this down? I forgot to pull on the strap. Say that's not going anywhere. It went somewhere. I mean, it didn't really go anywhere, but it moved around enough for the oil to leak out the front of the oil pan where the turbo drains are. And, you know, cool. Oh well. At least Elvis's bed won't rust now. Oh yeah, we'll just undo this strap here. No big deal. Not like it wasn't even tight anyway. Same with this one. I don't think I'll ever put an engine on a tire anymore. Last time I did this, I had it on a block of wood against the tailgate, but it was late last night and I didn't feel like figuring that out, so lesson learned. I take it you've done this a couple times?
Yeah, done it quite a few actually.
Did you guys make this arm just for doing this?
I think so. I think they had it made just for doing this.
I always think about the little things for efficiency in places like this. I feel like I'm watching Monsters Inc. with the doors. They get hung from the ceiling and go away. Watching my door go away. All right, so we're back here. They're gonna tear it apart. This is Brian. He's the owner, founder.
Yes, sir. Yeah, so we've been at this for a while. It's probably our, who knows, 5,000th engine that we're taking apart here at LME, if not more. So we'll get this thing torn apart. We're gonna try to use as many components as are in the engine currently. We're changing up some other things on the engine, but really focusing on keeping the current piston crank and rods, correct?
Yeah. Well, so we'll reuse all the bottom end if we can. It should be okay, but that's what we're here to find out. I've never touched this thing. It's been in there for 3 years. I've driven it, I don't even know how many miles. Okay. Several thousand. I did all of race week. And until I tore it apart, I hadn't even unbolted the driver's side header since I first put the thing together.
That's good. That's a good engine life for sure. So that's definitely nice.
Yeah, I don't know if you can tell.
Cylinder walls feel good. I mean, just initially, you know, there's no real scoring or anything like that. So even this surface rust is...
It looked like it just kind of wiped off.
Yeah, it's not that big. You know, we bumped the hone through it. It should come right out. And that'll be the biggest driver of if we really need, so if we need pistons or not. So you've got the condition of the pistons and then the condition of the cylinder walls. If the pistons can dimensionally be okay, but if the cylinder walls are way out of round or there's some issues there, then we may get into a condition where we have too much piston to wall clearance for the current pistons, and we would want to change pistons for that reason to go up to the next size. Or the pistons themselves are not dimensionally correct. There's something wrong with the you know, skirts are collapsed, or the ring lands are not flat anymore, or lifted ring lands, something like that would cause us to use new pistons. And then in that case, we would most likely go to the next size. If it's a 4125, we try to go to 4130 and get the cylinders nice and round and straight.
Well,
so that's what we'll find out here.
If it needed new pistons, I wouldn't consider that the worst thing ever, because after the fact, I would have made the compression higher.
Okay.
I think it's about 9.7 to 1 right now.
Yep.
But
okay.
If I were to do it again, I think, you know, bumping it up. Now knowing people know with E85 and stuff.
Sure.
But I mean, it never had a problem the way it was. It's just, if it's gonna do it, I'd you know,
you might as well take advantage, right?
And I also don't know what the chamber size will be on the new heads we're doing for this either.
Yeah, so it's going to be, we can alter them a little bit, so we can go anywhere from that 70 to 65 cc's with really no issues.
Sweet. What's the first step of tearing it apart?
He's already removed the rear cover, so we always remove the rear cover as we're putting it on the stand, so we don't have to take it back off to get the crank out of it. So rear cover's off. He's going to remove the balancer and then the front cover.
Yeah, I think we talked about the oil pressure weirdness that it was doing with where it would drop at the top of a pass. So I changed it and it helped, but it still never really made more than like 60 psi.
What pump is in it now?
I think it's the Melling 10295 or whatever.
295.
It's the one that they made. It's like high pressure, low volume or something for these blocks because of the way they're pathed differently than the stock ones.
10295, which is, it sounds like what you're explaining, and then you got the 10296, which is high pressure, high volume.
Yeah.
You've got the 10355, which is like kind of a replacement for the LSA block with the oil squirters, which is an increased volume over the 10296.
Interesting.
So this is probably a 10295 in it. We'll probably go back with a 296. That's kind of our go-to for, you know, with the truck pan. It works really well, holds pressure up top really well. It's just a good all-around.
I forget what was in there before. I don't know if it was the 355 before. It might have been, but it was even worse. It would, at the beginning of the pass, it would spike at like 90, and then it would go down to like 40 by the end of the pass.
So there's different things that can be happening. If it's pumping, like you said, if it's pumping too much oil and it's not draining back fast enough, it can deplete the oil that's in the oil pan itself. So you're basically sucking the pan dry. So adding oil can help with that, or reducing the volume in which the pump can turn. Or we can look at possibly restricting the oil inside the oil galley itself. In the dart block here, you have the oil galleys that you can manipulate the volume of oil going to the top end.
Yeah, I guess we'll find out what pump is in there pretty soon here, because I can't remember. I know those three numbers really well in my head.
Yep.
It had one of them, now it has one of the other ones. I don't know which one it is though. But when I changed it, it held better pressure, but it never made as much pressure.
How many quarts of oil did you have in it, you know?
I tried like 7, and it still, yeah, it still did it. It didn't seem to help. Is that a crank bolt that you turn down just to put in there for pressing stuff out?
Yeah, exactly. So because the threads are so deep in the crankshaft, so we put this. We have a turn down stock bolt, and then our puller centers on it, and it allows us to not have to, you know, go into the bottom of to hit the depth of the threads in the crank itself.
That's cool. I like little tips and tricks like that to like speed things up. That's the kind of stuff I pay attention to, and I like to talk about.
Helps. So the end, yeah, like the end of our puller has a taper on it. So other pullers, like you can take that taper off, then there's like little push rods that you can essentially, it looks like just like a push rod. So they're different lengths, but this is a more rigid setup because you only have a certain amount of diameter you can get in there. And those things can start bending.
Now we're about to find out what the lifters look like. Those are Johnson limited travel hydraulic lifters. This is not a solid roller motor, but these lifters are about as close as you can get to having one without having one.
With a nice spring and, you know, a properly designed valve train, 8,000 RPM with this lifter combination is not a problem.
Yeah, that's what I shifted this at, is 8 grand.
Yep.
It sounds really cool. I don't really need it, but I like it. I couldn't help but notice, is there a reason you're doing all this by hand instead of just buzzing it off with an impact?
Yeah, because you don't want to basically strip the bolt out. You know, if you're using a 6-point on a 6-point, it might be a little safer, but you want to do it by hand first and then basically strip it out or back it out with an impact later.
So you just do that for precaution when you're tearing one down?
Exactly.
You always do it by hand?
Yeah.
That's cool. It's the details. How do the lifters look?
What do you think, man? They look all right? Yeah, their lifters have normal wear on them. They look completely normal.
So we can reuse those?
Well, that's something we'll decide. I mean, if we, you know, once we get to the assembly part of it, they do look reusable.
Okay, that's promising. Is there anything scary in there?
That's what we're about to find out, so hopefully not.
Maybe some RTV, some orange paint from my garage floor that got in there somehow.
no bearing material or any type of material in here, so
we're good.
yeah.
No damage. That's a relief. Which oil pump is this?
It has a number on the back of it.
Oh, so we still can't find out yet.
You have to wait a little bit more.
Cool. The suspense builds. So before everything comes apart, we're gonna check the pickup tube, the pan clearance with the gasket in there, just to see if that might have something to do with why the oil pressure was acting the way it was. But you're saying if it's too far away, it can be a bad thing too.
Right, you want it right about a 1/4 inch away from the bottom of the pan, max about 350 thousandths, you know, max like 400, but getting up to where like a 1/2 inch of clearance between the bottom of the pan and the bottom of the pickup tube, you're just leaving that much volume of oil that you're not able to reach. Having it that 1/4 inch is optimal for allowing enough space for the oil to actually get up into the pickup tube without sacrificing the amount of oil that you can actually reach in the pan, the volume of oil.
Makes sense. If it's up higher, I know you can't get to the bottom, but does that also affect the amount of windage that can cause under the pickup? Like, you know, as far as like air getting in there and not just oil?
No, because you have your windage tray, so I mean, it's calmer down there. Obviously this is all upside down, so you know, your pan is right here, let's say, but if it's up in here, you know, let's say you had that much pickup to the pan clearance, you're leaving that much volume of oil across the entire pan that you're not being able to pull up. So you think you might have 7 quarts in it, but you're only able to reach, you know, let's say 6 of them.
Makes sense.
Yeah.
See, yeah, then it can only pump 6 up into the motor, and you got one just chilling
One just
all the
sitting
time.
at the bottom of the pan. So we'll just do a little quick down and dirty representation of what it is with clay.
I'm excited to get this figured out because, 1, I'm tired of this thing leaking oil. 2, I'm tired of wondering why the oil pressure isn't doing what it's supposed to do. So that'll give me just that much more peace of mind when we go to like really turn this thing up.
Right.
So when you first started, was it you doing all this?
Yeah, of course. When we first started, it was myself and my partner Pecos. We were doing all the teardown, machining, you know, answering the phones, the whole 9 yards. So every aspect of the machining and assembly of the engines, myself and my partner executed, and then we, you know, a little after that, brought on our first guy, and you know, the rest is history.
What did you do before this? Like,
before this, I went to high school. So went to high school. Was at a community college in upstate New York. That's where I'm from, is upstate New York. Was doing that whole deal. One of my buddies from high school that we used to, you know, do street cars, and I'd help him build his car. So we were doing the whole hot rodding thing, you know, on the weekends. He told me that he was going down to Houston, Texas to learn how to build race engines at the School of Automotive Machinists. So I'm like, damn, that's pretty badass, you know? So decided to quit school, quit college, and go to the trade school to learn how to build race engines. And pretty much the rest is history, man. We met my business partner at the school. We started our lone little shop. So for about 4 years, we were porting cylinder heads out of a small warehouse by hand, you know, LS heads. We were selling them online and to our local buddies and that type of thing. So ported tons and tons of cylinder heads by hand, hours after hours of that. So we're also working I was working at a machine shop full-time, building, you know, circle track and big block Chevy nitrous engines was our kind of forte there. And then porting cylinder heads after that, and then we finally built up enough local clientele to start late model engines, go full time. So that was in late 2003. So this is shit like 18 years later. We're rocking and rolling. There's about 19 of us here that are working. We're building about 400 engines a year, all LS and LT. We do some of the Gen 5 Vipers, some late model Hemis, but primarily our bread and butter is definitely the LS and LT market. High horsepower street cars, pretty much racing of any form. We can pretty much build it all.
how did your parents feel about just quitting everything? Like, I'm gonna quit everything, go to Texas for race cars.
They were actually pretty supportive of it. They were really supportive of it. So that was awesome to have that support. You know, they wanted me to follow my passion in a sense of and I'm thankful for that. You know, a lot of parents try to pigeonhole their kids into their dream or to what they're trying to do, but they kind of let me, you know, supported me in doing what I wanted to do. So that turned out to be a great thing, because I just put everything into the school and then into working and learning this whole game here, this whole game of racing engines. So, you know, living and breathing that for the last 19 years, I mean, we've really excelled, and that's I attribute a lot of that success to, you know, just my passion and my partners and everybody that works here. I mean, we just live and breathe this stuff, and it's what keeps us wanting to continually make our product better.
Well, that's why I like to dig a little bit and figure that stuff out, because like you said, a lot of parents don't want their kids to do something that's like maybe not going to work, or something stupid like that. They just want them to do something, you know, sit in your box and stay
something
there.
Safe, right?
Yeah.
So yeah, definitely. And then, you know, working at the other engine shop for the 4 years, and then jumping out onto our own, you know, there was definitely unknowns there, you know. And I mean, we started up with no money. Wasn't like we just had a big loan and started our whole deal with like unlimited funds or anything like that. We really bootstrapped the whole thing. Like I said, we were selling stuff online, cylinder heads and whatnot, to build up. So we buy one piece of equipment, then have another capability, in turn make more money, get another piece of equipment. So that's really how it all came about. So we started with cylinder heads. That's our kind of, a lot of people know us for our complete engines or short blocks, that type of thing. But right now, I mean, we're pumping out like almost 500 sets of heads a year, all CNC ported. We've got really the best headquarters in the game here, but you know, our origination of LME was ported cylinder heads. So our knowledge of airflow and making power through cylinder heads is really our base to our whole company.
When you started in 2003, where does where you're at right now stack up to what you thought you were going to be doing or what you wanted to do?
You know, it's a good question. It's like, you never really know, but I feel like we've exceeded my, how can I say? I knew we were gonna do really well, because our, like, we just never gave up, and our you know, our dedication to this craft. But you know, definitely having the right clientele and the right guys, you know, building a team that we have. I mean, it's I'm really thrilled about where our future is. So we're kicking ass right now, but I mean, it's almost like we're just getting going, because of the capabilities that we now have that we didn't have, you know, say 10 years ago. I mean, what we're getting into now is just next level. We've got some really good projects that are coming up that are going to set us off to the next level.
I've noticed that it's a common perspective of guys like you who have built stuff, is that doesn't matter what happened before. It's like right now, it's like I feel like we're just getting started. Like, yeah. all you're thinking about is, you know,
no doubt, yeah, dwelling on the past, or thinking about, you know, you can't rest on your achievements of the past. You know what I mean? You're great. You know, you had an achievement back then, but what are you doing tomorrow?
Yeah.
So I really feel, you know, strongly about that. Is, you know, it's like the guy that, you know, won the football game in high school or something. It's
yeah.
like, who gives a shit? And, you know,
peaked in high school.
Exactly. So, you know, looking forward to the future.
That's freaking cool. You know, that's why I make a point to do this, because no one ever talks about this stuff. No one ever puts it out there. And I know there's a lot of people out there, even kids, that are stuck in that box, and they don't have anybody to tell them that it's okay to get out of the box. So if they watch stuff like this, you know, you don't have to have your parents' approval to go follow your passion for stuff.
No doubt. I mean, today with the internet and you know, there's so many opportunities, it's just, you can pretty much find a way to monetize your passion almost no matter what it is, right? I mean, yeah. There's some way that you can either educate other people in that same field, or create a product and sell it. I mean, so I think it's definitely following. It makes it a lot easier, no doubt, when you're passionate about your craft, you know.
Yeah, it doesn't feel like work.
No.
Sometimes it does. But most of the time, you're like,
owning any business is a definitely has its ups and downs, but the fact that the passion of your field is what makes you get up and after those hits, you know?
Yeah.
You take hit after hit, and if you're not passionate about it, that's when you fall down. If you're passionate about it, you're gonna get up the next day and, you know, say,
you look forward to
going.
Mondays.
Exactly. What you got?
With the gasket, you say you're looking at almost 400.
400?
It's not even
But
like,
it's, you can't, this is supposed to have a bolt in it. This is kicked way out. You can't even get the pan on it without.
All right, so we're right at 400 then.
yeah,
We'll call it.
with the gasket, yeah, it's at 400 with the gasket.
Somewhere around there.
That's fine. So we'll tighten it up a little bit. So here's one thing that we're looking at is, so with this is just how it was, right?
Yeah.
So with one of the challenges, if you will, of getting a factory windage tray and oil pan on a dart block is the lack of bolts that the standard LS blocks have. So in the front here, we've got standoffs in the front, standoffs in the back from the main cap, and then you have these two bolts here that are threaded into the center of the main cap. And then you have this bolt, you have a standoff coming over here from the splayed bolt. So you can see that everything, when this was built, there was a lot of manipulation of these parts here, the windage tray and pickup tube, to get it to all jive. So 400, having it at 400 is not the end of the world. You know, like I said, you know, 250 to 400 max is where we're at. So we're on the max side. If we can get this up, well, when it's upside down a little bit closer to the pan,
Yeah.
We'll try to do that. So we'll
Sweet.
tighten it up a little bit. But all in all, I mean, it's not like bad.
We get to find out what oil pump is on there and maybe attribute that to some of whatever it was doing. I still don't know. These are the things I should remember, and I don't. Oh well. I will definitely not forget now. Once it does come off, and if that one goes back on or if something else goes back on, I will remember what it is. That's for sure. Moment of truth. What kind of pump is it?
It's a 10294.
Ah. The one number we didn't even bring up.
What is it?
A 94.
10294. Okay, so that is actually their, which goes along with what you were talking about. That is their newest pump. That's like the low volume pump.
Yeah. It was a low volume high pressure, or low volume standard pressure. I don't remember.
I'm not sure on the pressure, so I'm not sure that's the right pump for the application. I think we're going to go back with a 10296. We've just run so many of them on these blocks, and we'll be in good shape.
Now you can see what he was talking about here, the splayed main caps. I know I got to explain this because I used to not know what it meant either. You see the outer bolts kind of point to the side, so they're not all facing straight up. They splay out to give a little bit of a different clamping.
It kind of helps draw the cap out to the side, so you have more like the clamp load is multi-directional, if you will. It's not only perpendicular to the crank, but it's also being like drawn out as well, which is a good design.
Was that done to mimic the cross bolt-ish of the stock block?
So like the cross bolt is not necessarily all that. I mean, some would argue, dart being one of them, that the splayed cap is a stronger method of clamping the main caps than the 6-bolt, you know, the cross bolt of the LS. So I actually spoke with Richard at Dart about that in the very beginning, and he was explaining to us, you know, his theories behind, you know, why the splayed cap is a better clamping method than the LS traditional cross bolt.
Are we still not allowed to look at the cam bearings? I know that's like #1 rule in LS world. Don't ever look at the cam bearings.
No, I mean, you can look at them, they're fine. You can't see a whole lot right now because the crank is in there.
Oh, yeah, I mean, you know, with the stock motors, every time you pull a cam out, the cam bearings look absolutely disgusting.
Yeah.
And they just say, don't look at it, it's fine, put it back in. How's the cam look?
It looks all right. There's not any beat up loads I don't really see.
That's good.
Needs to be polished, but
So what's the procedure now that the cam is out and it's just the bottom end left?
yeah. So you check deck height, see how far the piston is in or out of the hole. 5.
So do you rock the piston on the pin both ways and split the difference?
So, yep.
Huh.
Plus 0.5. Should be in the hole 10.
Is that good? I don't know.
It doesn't really matter. It just affects the compression ratio. Compression ratio is going to be lower the further the piston is in the hole. But you can only have it, you know, one would say, okay, we could raise the compression by continually increasing the height of the piston in the block. But you can only go so much as where the piston won't hit, at some point the piston will hit the cylinder head. So that's your quench.
Yeah.
You know, your quench distance is the piston at TDC in relation to the deck surface, taking into account the gasket thickness. So this is 10 in the hole. If we were running a 50 gasket, we would have 60 quench. If we cut 10 off the block, we would then have 50 quench. We can dial in the compression ratio. So like by taking 10 off the deck of the block and running a 50 gasket, we can raise the compression probably about like 0.2 or so, maybe like a quarter of a point of compression by cutting the block.
Oh wow.
That much. So it has an effect. So when we look at the new chamber volume, we'll measure the volume of the piston, and then we know how far it is in or out of the hole. Now we can say, let's put it 0 deck, you know, 52 gasket, and you know, 66 cc's or whatever we might end up with, and we might be able to get that compression from 10.7 to, you know, like 11.2 maybe or something.
That'd be cool.
Yeah, so there's always a manipulation that can be done with how the block is machined and what head gaskets and all of that, while keeping the same pistons. You can only make small swings, you know?
Yeah.
If we really wanted to make a change, then we would need a different piston.
What that does is make more power out of boost. The shirt I'm wearing in this video is a new one that you can get on the website right now. We'll check out an example here. Okay, don't ask about the smashed laptop, but yeah, this one right here, it's like GM good wrench style. It's on the website right now. The link is in the description. And also, Logan does all of the merch handling, packing now. That's her job. And if you use the tip function, it goes straight to her, which is kind of a big deal right now because old Dick Licker hasn't been in videos because he's had a nagging eye injury and he has to get surgery on his eye tomorrow. It's pretty bad. Yeah. So, and it's quite expensive. So if you buy a shirt and use the tip function, it helps Ruger with his surgery. Anyway, back to the video. Theoretically light up faster and have more nut when you're, you know, don't have the boost controller on and that kind of stuff.
Just like we're measuring the chamber volume of the cylinder head, we can do that to the piston as well. And actually we'll clean all the carbon out of it and we'll know exactly what that volume is.
So they've written the cylinder number on there?
Just number in the rods.
I always wondered what tool made those little things.
Yeah, it's a little air engraver. Piston looks like it's wearing pretty well, so that contact patch right there is pretty, you know, is normal and looks good. I mean, you got a little scuffing, but that's kind of nature of the beast. You know, 1700 rear wheel. They're gonna have some wear on them ultimately, but that looks promising. The bearing, there's a little scuffing there from, you know, you could say that maybe a little lack of oil, but it's definitely not wiped out. It looks actually pretty clean. Like a lot of times you'll see these bearings are like a tri-metal bearing like this. It's very soft babbitt material on the face, so that allows foreign material to get embedded. They call it the embeddability of the bearing, and that allows the material to be embedded into the face of the bearing and not stay on the surface. So it kind of just like eats that debris up and keeps on going. Whereas a factory bearing, like today's factory bearings, are a harder, an aluminum bearing, and it's not as soft as this babbitt material. So you know, all of your like H series racing bearings are a babbitt, which has better embeddability. But you'll see, like if there's a lot of trash run through the engine, you'll see like a bunch of speckles. You don't see that here. Maybe a little bit of lack of oil, like we were talking about, from the scuffing there. But all in all, pretty decent. Here's the cap end. So this is seeing all of the cylinder pressure. You know, the rod side, the beam side is seeing all the cylinder pressure, where this is kind of seeing your, you know, the when the piston is coming back down,
catching it from going through the head.
Yeah, exactly. So all in all, not too bad there. And this is the one where you had the head gasket issue, right? Yeah. Obviously, because it's, you know, clean.
Seemed clean.
But then, as far as the rings go, Second ring is wearing well. It's a tapered ring, so you'll see the wear at the very bottom. See how it's shiny at the very bottom?
Yeah.
And it's black right above it. The shiny part is the part that's, you know, sealing. So it's a tapered ring where it's kind of scraping the oil down as the piston's going down. When you see them washed out or completely worn out, it'll be shiny across the whole face of the ring. So this is wearing properly. And then the top ring, did this thing have good blow by, or did it?
I just had the fenders, the valve covers vented like at the fender, and there would be condensation and wetness there after I make a pass, but it wasn't like
chewing out of the breather.
No, it never did that.
Yeah, so that looks good. So what we'll do is, you know, we'll take the rings off and we can pin gauge them, so we can actually have gauges that we can put in the ring lands to. It's kind of like not a no gauge, but there's little pins that are, you know, like a 2/10 increments. So we'll be able to understand how consistent the ring lands are in inspecting the pistons to make sure that they're usable to go back into the engine. And then we'll measure the skirts really well. You know, we may just coat the skirts, kind of just to say we did, put a little anti-friction coating on the skirts and kind of bring them back to like a more of a new condition.
Yeah, I always wondered why.
It'll also give us a little bit of more material to work with in the bore. You know, we can take a half. Basically, you add about a half thou of material with the coating, and then we can take a half out, and we'll still be at the same piston wall clearance.
I always wondered why there was no coating on it, and I think they told me that it didn't need it or
it doesn't.
something.
So we're not. There's a lot of people that are, you know, just I think a little overly reliant, or just, you know, they think they need coatings on everything. A good piston, like CP pistons, they have a really the way that their you know, skirt shapes are. I mean, all the main piston manufacturers these days, they got it down pretty well. But those pistons look good, and you know, there's the anti-friction coating on the skirts. You would pretty much see the same thing, just with coatings in the areas where this is not rough. You know what I mean? End result is pretty much the same. So a well-designed piston and adequate lubrication is the biggest thing, and no matter what coatings you have, if you don't have the proper oil on the cylinder walls, it's not going to do anything.
Makes sense.
We're not too. Some of our highest horsepower, you know, baddest race engines that we've ever built have zero coatings on the pistons. It's not going to make or break you when everything else is right. They definitely can help, you know, if you have a short burst of like you know, an overheating situation or a lack of oil for a shorter period of time, but it's not the end all be all.
Yeah, I know you always see people with these like 16 different coatings. It's like blue on the sides and gold on the top. Yeah. Like I never understood why.
We don't get too much into that. There's money that you can spend. You know, sometimes guys will have, you know, they'll have $1,000 in coatings, and they'll have, you know, like let's say a lifter that is, you know, it's like put the money in the right spots first, and then if your budget allows, then you can start doing things like that. But you'd rather have, you know, the proper lifter and proper valve train components, or a better quality connecting rod. You know, if there's a difference between going from like a Chinese rod to an American made rod or something, it's a few $100 difference in price. I'd rather have the better quality rod than some coatings on my pistons.
Yeah, that you can't see anyway.
Yeah, or that are really going to make zero benefit for you. But you can kind of feel when we're putting it together. We obviously will measure the thrust. That's the end play of the crank, front to back. But it feels good. It's not excessive, but you can tell that things are probably pretty happy in here. I say that, but the way that this crank is spinning, you can see how it whips like this. You know, if you had like a bent crank or something that was pretty severely wrong, the crank will not spin in this manner when it is operating well.
That's good. Now you were saying with what was the terminology used for the way the bearing can absorb material?
Embeddability?
Yeah, the embeddability. Is that something that you want because it can just absorb the crud instead of scraping stuff up?
Yeah, so the H series bearings that pretty much all of us are going to use in a high performance application like this, it's a tri-metal bearing. It has a steel back, babbitt and tin, and the babbitt is a soft material that will actually absorb that material, you know, the foreign debris.
Is that what's going on here? It's got that black on there also. There's a couple scratches in it.
So no, that is a coating. That is a coated bearing. So it's kind of be like a anti-friction or phosphorus coating on the face of the bearing. That's a Babbitt bearing as well, but this has like almost no wear. I mean, those little scratches are just, you know, from very minor imperfections in the journal, let's say, or some little small piece of trash that went through there. Yeah, and the journals look good. I mean, there's really no obvious scoring or any heat or anything like that. I mean, the bearings look all consistent, so it's looking good.
Is he coming back when we assemble it or not? Is he gonna film that?
I don't know.
I'd like to. If that's like be cool. Unless you got all kinds of secrets you don't want to share.
Man, we're pretty open.
I found that to be a case for a lot of high level operating places. They don't care if people know every single detail they do, because they know that most of their competitors are not dedicated enough to even attempt any of that.
Yeah, I agree. I mean, it's good stuff. I mean, with the internet, pretty much all information is available.
Yeah.
You know, it's a matter of applying that information consistently. A lot of engine building is just attention to detail and, you know, caring about the product, honestly. Cleanliness, I mean, that's huge. You know, when you're in the assembly room, and the way that you can do the best machine work in the world, and if you don't clean the block and the components properly after the fact, all that goes to shit. So it's, you know, you have a perfectly machined block, but you don't take the time to clean it properly. You're almost, you know, you get it on the dyno and the thing can, all the perfect bearing clearances, this, that, and the other, and it has an issue because of the foreign material that's left in the block itself. So cleanliness, we spend a lot of time, our cleaning procedures and, you know, our attention to the surface finishes. That's a big thing. In today's engines, you can get away with sloppy surface finishes that you could in years past. So with the type of rings being used and the way that these cylinder walls need to be honed, it's super important. So we use a thing called a profilometer. It's a measuring device, profilometer, that can measure the surface finish. So we measure our main and rod journal surface finishes, our deck surface, as well as our cylinder wall surface finishes to ensure that everything is machined properly.
Did you say before that you wanted to engine dyno this NA when it was done?
Yeah, that way we know that it's all
That'll be cool.
part of our standard, you know, long block process. We'll run it on the dyno, break it in. That allows us to, you know, we got 1002 sensors on the dyno, so one per primary tube, one in each collector. Allows us to monitor and adjust air-fuel ratio per cylinder. It's always nice to test your product, you know?
Yeah, you know it works.
Any good company will test its product before they ship it out, you know? You're buying a blender, and you like plug it in and make sure it goes before they send it out the door.
I've always wondered what this thing would do naturally aspirated. I just kind of had to guess, thinking 14 pounds of boost divided in half. You know, eyeball it.
Something like this will typically make like 650.
With a turbo cam in it?
Yeah, like 625 to 700, depending on all the, you know, nuances of that particular engine, is typical.
That'll be cool. I definitely want to be there for that. Yeah, that'd be fun.
These have register, huh? At least that's good. Yeah, so you see how it's coming out, where he's having to use a slide hammer to actually get it off of the block.
Yeah.
You'll take them apart if there's a lot of if the engine was experiencing detonation and, you know, was unhappy in that regard. You'll see where the caps, they'll actually kind of be like flexed like this, where they won't have the press fit or register into the block anymore, and that's extremely bad. You've got a couple things going on. Whenever you're making the power that you're making, stuff's going to be moving around quite a bit. You know, no matter what, you can have the best crank, the best components you can buy, and there's always going to be some level of flex and distortion there. How much is the question, right? So knowing that the caps are coming off like this, if you could literally just pull the cap off, where we took apart an engine yesterday, and you could just pull it. Yeah, you could pull the cap off and you could move it side to side to an extent, and it was another block similar to this. That is not good. That means that engine was experiencing some significant detonation or to an extent. So having the caps where they have good register is is a good thing because we can go into the rebuild of the block knowing that it's a solid foundation.
Interesting.
Yeah.
So you learn a lot about what you need to do to redo the engine just while you're taking it apart, by how it comes
100%.
apart.
Exactly.
Yeah, there's a lot more to that than I would have thought, because, you know, regular person who doesn't do this thing, so you just take it apart, you look at the bearings and they're messed up or they're not. But even just simple things like the way stuff comes apart is not something I would have thought about in terms of diagnosing what it is.
The number 2 and number 4 will typically have the most wear. That's where you're going to see the most crank flex. So it does appear that there is some sort of, you know, some level of oil starvation to the engine. Yeah,
This
so like,
one lost its total crush right here.
yeah, so you've got some stuff that's moving around there. See how that kind of just floats around? So that can be a indicator of detonation, or just by how much that crank is moving around. Which, you know, whenever you're making 1700 to the tire, like I said, stuff is going to move around, things are going to wear, and it's not necessarily anything or anyone's fault. It just is what it is.
Yeah. So is this the one that was moving a little bit?
Yeah.
So that one's got
It's got wear on it.
a little bit of
You
wear.
see the copper there?
Yeah.
And you can see it lost its crush, so, I mean...
So on the block, the caps take all the beating, as opposed to on the connecting rod, the beam side takes the beating, right?
Yeah.
You have your upper and lower bearings. These are the uppers, and the cap is the lower. On the beam side of the rod is the upper, and the cap is the lower. So the bearings we were just looking at, we're taking all of the brunt of all of the power, whereas the uppers here they look in much better shape.
Yeah.
Can you see that?
Yeah, it's visible.
So there's a lot less wear on the lowers than there are on the uppers. Decent. You can see here, like here.
This is all super interesting stuff. Hope you guys are learning things.
So you can see here that this is the one that had the loosest cap, or loosest bearing.
Yeah.
So that's kind of like what we'd call beat out of it. I mean, it's pretty, that's loose. And you can see there are some, it's got down to the babbitt there where it's copper color. So that was wearing. I mean, at some point, this would be your first point of failure if you're gonna have a bearing issue. It would have been this one right here over some course of time. So you caught it at a good time. You can see on the here,
Yeah.
and here. So like that's called fretting. That's where the cap was actually, you know, in a sense, dancing around on the block surface here. So there's some metal transfer between the block and the cap.
Yeah, you can
So
definitely see that.
Yep. Whereas on as opposed to this one here, there's like literally none of that.
Yeah, that's pretty apparent.
Sometimes you'll see it where it's on every cap everywhere. So what we would do to fix that is we can actually cut the caps. We can cut this surface on a cap grinder, and that will shrink the diameter of the hole, and we'll do them all the same. So it'll go through that process. We're gonna line home the block. First we'll torque it all down without the bearings in it. We'll use a dial indicator, and we'll actually, or a dial bore gauge, and we will be able to measure the ID of the housing board and put it at the spec that we like it.
Is there anything noteworthy that you look at on these that the bearings don't tell you?
Yeah, you look for some obvious scoring and, you know, cracking, anything like that. You can see stress cracks sometimes in the, you know, in the journals, but there's none of that on this. I mean, one thing that we will do, this crank looks really good. Part of our blueprinting process is we'll actually trim up the main. So we indicate the crank in from the snout to the rear seal, and we'll actually trim up all of the main journals, so we know that they're perfectly in line with each other and round and straight. We'll look at this. We'll look at the oil holes. We'll usually chamfer those a little bit better than they come from the manufacturer, and then we ensure that there's a 2RA or better surface finish on the journals when it goes back into the assembly room. Most manufactured cranks come in at about a 4 to 6 RA. If we can get them to a 2 with minimal expense, that's like a home run.
We're gonna check out all the other stuff in here, but that'll be a different tour video. This one's just for the teardown and diagnosis of the Escalade's engine.
Yeah, so pretty much, I mean, all in all, I would say that everything is looking pretty decent. I'm pleasantly surprised about that. You know, I mean, you never know what you're gonna see, not knowing the true history of the engine and all of that. You know, the pistons seem like they're in pretty good shape. The crank looks definitely usable. We'll get the line bone straightened out.
Yeah, for the amount of oil weirdness I've had with this, the amount I've driven it, and the power level that it's made, and the weight that it's pushing at that power level.
Yeah, man, I'd say it's doing pretty well, for sure.
I'm cool with it. It's a big sigh of relief.
Yeah, at least we're not like, oh, crank is cracked.
Yeah.
Box.
Yeah, now everything's out of stock because everything's out of stock
Exactly.
everywhere, and it's that just means that we can get back on the road quicker.
We're gonna do the 1/2-inch studs.
Yeah.
So we'll put it up in the machine. We'll drill and tap it for the 1/2-inch studs. We're gonna so basically it's gonna go through our blueprinting process. We'll line hone the block, get that lined out. It'll go into our CNC machine, and we'll deck the block. At that time, we'll also do the 1/2-inch studs. It'll then go into the cylinder hone. We're not going to take much material. We're going to really take the minimal amount of material to maintain the least amount of piston wall clearance, because the pistons look good, so they weren't showing signs of inadequate piston wall clearance, so we don't want to go, you know, too far to the other side, like I explained earlier. So we're going to take out the minimal amount of material, but it's a balance. But you want to have, sometimes you'll sacrifice sizing for geometry. So we would rather take out, let's say, another 1/2 thousandths to get the cylinders nice and round and straight and the right cylinder surface finish, than to leave them the geometry not as good, but keeping the size a 1/2 thousandth smaller. If you
makes
see
sense.
what I'm saying there. So geometry is more important than sizing in this case here. We want to optimize ring seal. Yeah, other than that, I mean, it'll go through our whole deal. We'll just check we'll verify the balance of the crankshaft just to say we did. Obviously it looks like it's in good spec, but just part of our process. I think we're also going to do we're going to receiver group the block, and then also put in the hoops into the cylinder heads.
Oh, so we're doing that too.
Turn it up. We're going to run a copper gasket. That's going to give you the best clamping cylinder pressure sealing that you can. Over let's say just an MLS gasket and 1/2-inch studs.
So, and we're gonna do some Rodex castings on here your way. Do you have any of those sitting around here that we could check out?
Yeah, I'm sure we do.
Or even just the raw castings, so people can see. You can see how they come.
For sure.
Yeah, we'll check that out stuff in the tour video, wherever the cylinder head area is. I don't even know. We just walk right back here. So
yep.
I'm pretty pumped to check that out.
Yeah, so we'll do some more checking on this stuff and make sure it's all good. He's gonna jet wash the block, get it ready for machine work, and we'll be on our way.
Sweet. Yeah, make sure you head over to the tour video that'll also be on my channel. And this video is gonna come up first, so I'm gonna have to wait a couple days, but it'll be there. So make sure you hit that subscribe button. And where can they find you on social media, website, contact, anything?
Instagram, Late Model Engines, Facebook, Late Model Engines everywhere.
Solid branding.
Exactly. Exactly.
Yeah, let's go start this tour video.